In this video, we will solve problems from exercise 3.7. Question number 1. If a plus b plus c is equal to 180 degrees, prove that sine 2a plus sine 2b plus sine 2c is equal to 4 times sine a, sine b, sine c. We have the full set of formulas here that we'll be using in this problem. Now, let's take the first two elements here and let's apply this sine c plus sine d onto this. So this, or LHS, will become, substituting or replacing sine 2a plus sine 2b using this formula, this becomes 2 times sine 2a plus 2b divided by 2 into cos 2a minus 2b divided by 2, and let's replace sine 2c with this formula here, which is sine 2a is equal to 2 sine a cos a. So this becomes 2 sine c cos c. Further simplifying this, this becomes 2 times sine a plus b into cos a minus b plus 2 times sine c cos c. Now this, we can write this as 2 sine c cos a minus b plus 2 sine c cos c. Now we have replaced sine a plus b to be sine c because we are given the condition that a plus b plus c is equal to 180 degrees. Therefore, our sine a plus b will be equal to sine 180 minus c here, 180 degrees minus c, which is nothing but sine c. So you can say the since. So now taking the 2 sine c as a common term outside, this becomes 2 sine c within bracket cos a minus b plus cos c. Again, we can replace cos c to be minus cos a plus b. So 2 sine c into cos a minus b minus cos a plus b, since cos c is equal to cos 180 degrees minus a plus b, which is equal to cos minus cos a plus b. Okay. So further, so close bracket here. Now further applying cos a minus b minus cos a plus b using this formula here, cos c minus cos d, you would get 2 sine c into 2 times sine 2a by 2 sine 2b by 2, which is equal to 2 sine c 4. You have a 2 here and you have a 2 here, so it's 4 sine c sine a sine b. You can rearrange this as 4 times sine a sine b sine c, which is equal to our RHS. Hence the proof. Part 2 of question number 1. Cos a plus cos b minus cos c is equal to minus 1 plus 4 times cos a by 2 cos b by 2 sine c by 2. So let's take the left hand side, which is cos a plus cos b minus cos c. Now let's take cos A or cos B and let's apply this formula here. So this will become 2 times cos A plus B by 2 into cos A minus B by 2 minus cos C. Now cos A plus B by 2 is sin C by 2, 2 times sin C by 2 cos A minus B by 2, and we can replace cos C using the formula here, taking A as C by 2. This becomes now minus of, within bracket, 1 minus 2 times sin squared C by 2. Okay, so further simplifying this, this becomes 2 sin C by 2 cos A minus B by 2 minus 1 plus 2 times sin squared C by 2. Let's leave the minus 1 here as it is, plus let's take 2 sin C by 2 as a common term, 2 sin C by 2, then within bracket we will have cos A minus B by 2 plus sin C by 2. We can replace sin C by 2 with cos A plus B by 2. So this will become minus 1 plus 2 sin C by 2 within bracket cos A minus B by 2 plus cos A plus B by 2. Okay, since sin C by 2 is equal to cos A plus B by 2. Similarly here we had replaced cos A plus B by 2 with sin C by 2. So I will write here cos A plus B by 2 is equal to sin C by 2. Now further applying the same formula here onto this expression, cos A minus B by 2 plus cos A plus B by 2, this becomes minus 1 plus 2 times sin C by 2 into 2 times cos 2A by 4 into cos 2B by 4, which is equal to minus 1 plus 2 times sin C by 2 cos A by 2. So this will be a 4 and cos B by 2. So you can rearrange this as minus 1 plus 4 cos A by 2 cos B by 2 sin C by 2, which is equal to our right hand side, hence the proof. The third part of question number 1. Prove sin squared A plus cos squared sin squared A plus sin squared B plus sin squared C is equal to 2 plus 2 cos A cos B cos C. So let's take the left hand side here, which is equal to sin squared A plus sin squared B plus sin squared C. Now what we can do is, using this formula here, we can say sin squared A is equal to 1 minus cos 2A divided by 2. So let's apply this formula onto this. So this becomes 1 minus cos 2a by 2 plus 1 minus cos 2b by 2 plus 1 minus cos 2c by 2. So now we can take the common terms out. So this will become 3 by 2 minus 1 by 2, and within bracket cos 2a plus cos 2b plus cos 2c. Now cos 2a and cos 2b, by applying this formula here, will become, so this part will now become 2 times cos a plus b cos a minus b, plus for cos 2c, let's apply this formula here. So this will become 2 times cos squared c minus 1. If you open the brackets and rearrange this, this will become 3 by 2. Then this 1 by 2, when it goes inside, this becomes plus 1 by 2. And when you multiply with this term, 2 and 2 will get cancelled. Minus cos a plus b into cos a minus b. Again, this 2 will get cancelled. So this is minus cos squared c. Now we can change this cos a plus b as minus cos c. So this will become plus 1 by 2 here, plus cos c cos a minus b minus cos squared c. So this will further become 3 by 2 plus 1 by 2 plus cos c. You can take that as a common term. Then this becomes cos a minus b minus cos c. Again, so let's just make a note here. Since cos a plus b is equal to minus cos c, because of our condition, which is a plus b plus c is equal to 180 degrees. So then further, now we can change this as 2. 3 by 2 plus 1 by 2 will be 4 by 2. That's 2. Plus, leave the cos c as it is. Then within bracket you have a cos a minus b. Then again this cos c will become minus cos a plus b. So this is plus cos a plus b. Now again, using the same formula here, this becomes 2 plus cos c within bracket 2 times cos a cos b. So opening the bracket here will be 2 plus 2 here. Then we can rearrange this as cos a cos b cos c, which is equal to our right hand side. Part 4 of question number 1. To prove sin squared a plus sin squared b minus sin squared c is equal to 2 sin a sin b cos c, and you're given a plus b plus c is equal to 180 degrees. Now again, using this formula here, we can rewrite our sin squared a is equal to 1 minus cos 2a divided by 2. Therefore, our LHS will now become 1 minus cos 2a by 2 plus 1 minus cos 2b by 2 minus 1 minus cos 2c by 2. So rearranging this, this will become 1 by 2 you have a plus 1 by 2, plus 1 by 2, minus 1 by 2. So this will become 1 by 2. Then minus 1 by 2 into cos 2a plus cos 2b and a minus cos 2c, because you have a minus here. So minus into minus will be plus, so this will be a plus here. Right. So this is now equal to 1 by 2 minus, let's retain this 1 by 2. Now cos 2a plus cos 2b, using this formula here, this will now become, so let's have the big brackets, 2 times cos a plus b cos a minus b. And let's rearrange cos 2c using this formula here to be minus 2 times cos squared c minus 1. Now again rearranging this entire thing, and cos a plus b is equal to minus cos c, so this becomes half. If you open the brackets, this will be a plus, 2 and 2 will get cancelled, cos c, it's a plus because cos a plus b is minus cos c, so minus into minus will become a plus here, into cos a minus b, and then for the second term you have again this 2 and you have a 2 here, so this becomes plus cos squared c, then a minus into minus plus, plus into minus a minus, minus 1 by 2. So these two terms will now disappear and take the cos c as a common term. So this becomes cos a minus b plus cos c within brackets, the big brackets here. Now we can replace cos c, since is equal to minus cos a plus b. Let's keep the cos c outside as it is, and this cos a minus b as it is. This cos c will become minus cos a plus b. So cos a plus b minus cos a minus b, using this formula here, you would now get cos c into 2 times of sine a sine b, which if you rewrite this becomes 2 times sine a sine b, this is a c here, cos c, which is equal to our right hand side. Part 5 of question number 1. Prove that tan a by 2, tan b by 2 plus tan b by 2, tan c by 2 plus tan c by 2, tan a by 2 is equal to 1. And we are given the condition a plus b plus c is equal to 180 degrees. Okay, so given a plus b plus c is equal to 180 degrees. So this would imply that a plus b plus c divided by 2 is equal to 90 degrees. And this would imply that a plus b divided by 2 is equal to 90 degrees minus c by 2. Therefore, tan of a plus b divided by 2 will be equal to tan of 90 degrees minus c by 2. Now this we know, tan 90 degrees minus c by 2 will be cot c by 2. Now let's replace tan a plus b by 2 with the formula of tan a plus b. So this will become, taking a as a by 2 and b as b by 2, the left hand side will now become tan a by 2 plus tan b by 2 divided by 1 minus tan a by 2 tan b by 2. And our cot c by 2 is nothing but 1 divided by tan c by 2. So let's cross multiply. So this will now become tan a by 2 plus tan b by 2 multiplying with tan c by 2, and this is equal to, and bringing this to the right hand side here, 1 minus tan a by 2 tan b by 2. Let's now multiply the terms outside the bracket and remove the bracket. So this will become tan a by 2 tan c by 2 plus tan b by 2 tan c by 2 is equal to 1 minus tan a by 2 tan b by 2. Now bringing this to the left hand side, this will now become tan a by 2 tan b by 2, which is this term here, you're bringing it to the left hand side. Then let's put this term next, tan b by 2 tan c by 2. Then the first term here is tan, rearranging this, c by 2 tan a by 2 is equal to 1. Therefore, LHS is equal to RHS. Hence the proof. Part 6. Prove that sin A plus sin B plus sin C is equal to 4 cos A by 2 cos B by 2 cos C by 2, and you're given the condition A plus B plus C is equal to 180 degrees. So on the left hand side, which is equal to sin A plus sin B plus sin C. So let's apply this formula here, sin C plus sin D onto sin A plus sin B. So this will now become 2 times sin A plus B by 2 into cos A minus B by 2, and for sin C, let's apply this formula here, assuming A to be C by 2. So this will become 2 times sin C by 2 cos C by 2. Again, A plus B, sin A plus B by 2 will be cos C by 2. So this is equal to 2 times cos C by 2 into cos A minus B by 2 plus 2 times sin C by 2 cos C by 2, since cos A plus sin A plus B by 2 is equal to cos C by 2. So now rearranging this here, taking the cos C by 2 and the 2 outside, so this becomes 2 cos C by 2, and within bracket you have cos a minus b by 2 plus sine c by 2. Again, sine c by 2 is nothing but cos a plus b by 2. So this will become 2 times cos c by 2, and within bracket cos a minus b by 2 plus cos a plus b by 2. Further, applying this formula here, cos c plus cos t onto this, this will now become 2 times cos c by 2 into 2 times cos a by 2 cos b by 2. Therefore, simplifying this, removing the brackets, 4 times cos a by 2 cos b by 2 cos c by 2, which is equal to our RHS, hence the proof. Part 7 of question number 1. Sine b plus c minus a plus sine c plus a minus b plus sine a plus b minus c. We have to prove that this is equal to 4 sine a, sine b, sine c, and you're given a plus b plus c is equal to 180 degrees. So let's say given a plus b plus c is equal to 180 degrees. Therefore, b plus c is equal to 180 degrees minus a. So, we can say that b plus c minus a, which is our first term here, is equal to 180 degrees minus a minus a. So that would mean b plus c minus a is equal to 180 degrees minus 2a. So this implies sine b plus c minus a is equal to sine 180 degrees minus 2a. So sine 180, so we can say that b plus c minus a is equal to sine 180 degrees minus 2a will be equal to sine 2a. Sine 2a. Therefore, the first term here is sine 2a. Similarly, we can prove using the same method, sine c plus a minus b is equal to sine 2b, and sine a plus b minus c is equal to sine 2c. Therefore, our left hand side will now be equal to sine 2a plus sine 2b plus sine 2c. Now this is equal to 4 times sine a, sine b, sine c, using the result from question number 1, first part. That is equal to right hand side, hence the proof.
Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.